After your introduction, I will share. I will ask.
Okay, sir. Good evening, everyone. Namaste. A very warm welcome to all the respected guests, mentors, coordinators, faculty members, students, innovators, researchers, and future technology leaders joining us today. I'm Manish Kumar, student coordinator at KIYE Foundation, and it is my privilege to host today's Stocks Lecture 15. Before we begin, I request everyone to drop your name, college name, and branch in the chat session. It is wonderful to see participants joining us from different colleges, universities across the country. Everyone joining us live, welcome aboard. Today, we all are connected by one mission to learn, to innovate, to serve the nation through science and technology. KY Foundation is a non-profitable organization dedicated to empower students through innovation, leadership, technology, aerospace, defense, space education, entrepreneurship, and career opportunities. Our mission is to bridge the gap between academics industry by connecting students with eminent scientists, researchers, entrepreneurs, defense experts, and professionals from diverse fields. Through workshops, lectures, innovation, internships, research initiative, and skill development program, KY Foundation continues to inspire young minds to become future innovators and national builders. STOC stands for Space, Aerospace, and Futuristic Technologies. This initiative aims to inspire students towards science, research, innovation, entrepreneurship, and emerging technologies. Our mission includes 52 lectures, 52 speakers, 52 topics, 52 weeks of inspiration. Each session brings together distinguished scientists, defense experts, entrepreneurs, researchers, and industry leaders to share their knowledge and experience, to learn, to connect, to inspire, and grow. Today's theme is defense research, naval technology, and India's journey towards technological self-reliance. India has made a remarkable progress in indigenous defense systems, missile technology, underwater weapon systems, and advanced naval research. Behind these achievements are visionary scientists and engineers whose dedication has strengthened our nation's security and technological capabilities. If you believe India will continue to through indigenous innovation, type Jai Hind in the chat session. Before introducing our distinguished guest speaker, let us watch a short audio-visual presentation showcasing the vision, mission, and activities of KY Foundation. I request one of our coordinators to please play the AV. Thank you. Thank you. If you found the presentation inspiring, please drop a rocket on the chat session. Now, I would like to invite our student coordinator, Ms. Janavi, to share our journey with KY Foundation. Janavi, the virtual stage is all yours.
Thank you, Manish. Good evening, everyone, respected dignitaries, mentors, and young leaders. I'm Sri Janvi, an active student coordinator at Kalam Institution of Youth Excellence, and I'm happy to share my experiences and learning with you all today. My journey with KIY began in 2025 when I joined as coordinator at Vigyan Vaibhav 2K25. It was a wonderful opportunity that introduced me to the world of leadership, teamwork, and event management. Working closely with students, coordinators, and mentors helped me gain confidence and develop a great sense of responsibility. As my journey continued, I had this opportunity to be a part of several other KIY initiatives and events, each of which contributed to my growth personally in different ways. These experiences helped me to step out of my comfort zone, interact with the people from different backgrounds, and improve my communication and leadership skills. Through the opportunities and experiences provided by KIYE, I have learned the importance of teamwork, dedication, and discipline. Every event came with its own challenge, but each challenge became a valuable lesson that helped me to grow both personally and professionally. As my work were recognized, I was given an incredible opportunity to pursue an internship at NRSC GD Betlam, where I am currently gaining valuable experience and practical knowledge. I sincerely believe that the guidance, opportunity, and encouragement provided by KIY played a major role to help me to achieve this milestone. I would like to express my heartfelt gratitude to our mentor, Dr. G. Satish Reddy Sir, for his constant encouragement and support. A special thanks to Naresh Indian Sir, whose guidance and motivation has inspired many of us today to dream big and work hard towards our goals. I'm truly grateful to KIY for all these opportunities and experiences it has given me, and I'm look forward to be a part of many more such experiences. Thank you, everyone. Jai Hind.
Thank you, Janavi, for your inspiring words. And now, the moment we all are been eagerly waiting for. It is my immense honor and privilege to introduce today's distinguished speaker, a renowned defense scientist, visionary leader, and mentor for KY Foundation, Dr. Y.Sreenivas Rao, sir. Dr. Y.Sreenivas Rao is a distinguished scientist and retired director of Naval Sciences and Technological Laboratory, NSTL, DRDO, one of India's premier defense laboratory dedicated to advanced naval systems and underwater technologies. And he is currently working as CTO of Gen Technologies. Throughout his remarkable career, he has contributed significant to India's indigenous defense research, naval technology, strategic systems, and advanced engineering programs. His leadership has inspired scientists, engineers, and researchers across the country and has strengthened India's journey towards technological self reliance and in defense excellence. Today, he joined us to share his valuable insights on defense research, naval technology, and India's journey towards technological self reliance. Dear friends, please welcome Dr. Y. Sreenivas sir with big round of virtual applause. Let's let us fill the chat session with welcome sir and express our heartfelt gratitude for joining us today. Sir, thank you very much sir accepting our invitation. It is great privilege to have you with us today sir. We are excited to learn from you your rich experience, knowledge, and contribution to the India's defense and research ecosystem. The virtual stage is all yours, sir. Now,
Good evening to the large student committee and I see some of my ex-colleague also, Mr. Ravi Gupta, who has contributed immensely for the defense system, is also there online. So, good evening, Ravi Gupta, sir.
Very good evening to you.
Good evening.
I'm glad to see you after a long time.
Yes, yes.
Yeah.
So, after my retirement as Director General Naval Science and Materials from DRDO, so I have been doing some consultancy or more of advisor, and I've been mentoring the young startups and students. And now, of late, last 2 months, I joined Zen Technologies Limited as Chief Technology Officer. And Zen is primarily into giving a lot of different solutions. We build some of the best simulators, all kinds of simulators for the armed personnel, the training simulators, and actually working simulators. We also are very strong into the counter drone systems. So today, topic I chose was drone and counter drone technology because today the war scenario has changed a lot, and you will find a network architectured drone attacks which are low cost, high intensive, and a counter attacks are the defining the war scenarios today. It's not only the war scenarios which is defining, it is infiltration is also defining on based on this. And in addition, for a general civil community also, drone has become a delivery mechanisms. Though we don't have a law today in India for a beyond line of sight drone unmanned systems, aerial systems, but there are countries where beyond line of sight unmanned aerial systems are allowed. And if this is allowed, we have a long delivery systems that are happening, especially Amazon and many other areas where the delivery mechanisms are happening because of drones. Today, what I'm going to give you students are the overview. They're all available. They're all open source. I'm not introducing anything new or a new technology which I don't want to introduce to you people. But then they're all going at a very, very fast pace. Why I brought this out is this is the area, the unmanned area is what is going to be, at least I pursue in the next 4 to 5 years, going to be a game changer. And how we handle this situation, how we counter this situation is what going to change, both in the civil sector and the defense sector. So I have a colleague of mine who will share the presentation. Bala, you can share our presentation.
Sure, sir.
So as he shares the presentation, the topic I would like to choose is, earlier we had a very few unmanned or a remote control systems, but now the systems have become micro level. The endurance limits are changing, the stealth levels are changing, the application levels, especially the camera or the delivery or the tracking systems are changing very fast. Stealth, I mean undetectable by the ground radar, and also if I have to attack it or jam it, it is coming out with a different technologies or different frequency hopping or some other technologies where it is avoiding. So it's a completely going to be a counter system in the today's world. So next slide. And most of the photographs I kept here are from the open source, and I request people not to use for any commercial requirements of this. Is only for to make you an understanding and available and to the topic of concern today. So I request this to be taken care of when you are using these systems. So I just run through these slides. There are about 13 topics are there. So what I talk will be on the types of drones, a basic physics of drone flight, and major subsystems in drone, and how a swarm and a simultaneous launch, which is now the order of the day, is going to be there, especially with AI coming and multi-agent AI coming, and how do we coordinate those to make the swarm really efficient and reliable system. Stealth and high-speed drones, which are especially nowadays used even for interceptions. High altitude dynamics. So even in the stratosphere, that is, if tomorrow I can launch a miniature drones even from a satellite-like objects, payloads that come in the drones, sensors, weapons, electronic warfare packages. How do I detect? How do I track? What are the mechanisms by which I can do it? And those are the systems that I will be covering a brief on the radars, electro-optic and IR sensors, RF-based sensors, acoustics, DPD sensors, then the counter drone. If it is a soft kill, what we call of jamming, spoofing, cyber takeover. Counter drone hard kill, like lasers, high power systems, rockets, guns, interceptors. Then command and control station, the kill chain integration. What are the world drone global technologies and counter US system landscape? Futures and carriers in this area. Next slide. So if you look at from the drone angle, we have a drones as low as 250 grams, small drones, and range less than 2 kilometers. I have seen some of the academic institutions also trying to build this, made of carbon fiber. Then we have combat drones. If you take the next level of drones, we can group it as small drones, which are about up to 25 kg, and then medium drones, which are about 600 kg. And then you have high endurance drones, which can go up to 24 hours more. And these have got a longer ranges also. Longer ranges, higher payloads. And we have payloads which can carry drones today, even 600 to 700 kgs, depending upon the fuel. These are all IC engines or a gas turbine based drones. They actually take off. They have a vertical lift drones are there, and you can also have a takeoff drones. But these are all beyond the line of sight. Today, currently in India, they are not operated because of the restrictions of the civil aviation restrictions we have, because the civil aviation ministry has clearly given a guideline that except for the line of sight drones, you cannot fly beyond the line of sight drones. But however, these are going to be a future. Then we have stealth capable drones, which are used mainly as an attack or a weapon release requirements. And then another area which is happening is loitering munitions, especially a swarm loitering munitions with a little bit higher payload capabilities, and which can go at a higher speeds than the normal drones. These go at about 160, 170 kilometers per hour, and in a swarm mode operations create a saturation attack. I'll come to that, what is saturation attack, when we cover the radar or the sensor technologies. Next. So if you look at the relations, globally, India is not far behind. Our own DRDO has developed very good unmanned vehicles with a lot of advanced technologies. And we have got huge network. Almost every city is now have a company which is building a drone. And in fact, my take is that drone should be become like a cottage industry. That is a huge requirement of drones India will have. But more important is, what are the components we are building? The motor, the propeller, the other controller, onboard systems, they are being made today in India by the Indian companies. So this is where we have to see that most of it will be indigenous. There are our own neighbors have also built very well good drones, and this is just a screenshot, but this is not the end. If you look at Europe, if you look at Pan Asia, everywhere people are building drones, and every time people are coming with newer and newer concepts. It's more of idea and engineering that is creating, and the application of drones also changing every day. It's coming out with a newer thought process. Next. If you look at this is a basic aerodynamics. This is for an engineering student. If you have to understand, any object has to lift, it has to have a force beyond the weight. Weight is the mass into gravity by which it has to weight. And there's some aerodynamic drag or a friction or some kind of a resistance which it will face. So it has to overcome this resistance, and the propeller thrust has to cater for this. This is a simple equation of lift, where you have got the air density, that is the resistance which a air take gives you, and the base and this together coupled force will give you a velocity, right? And this thrust is given by a rotors. So if you have a four-copter, we have a four rotors, then you can work out the power requirement of rotors based on this and the propeller efficiency. Ultimately, how do we control direction and stability is by varying the speeds of these rotors and giving a different wheel variations and also direction. If I have one propeller in one direction, the other propeller in direction, that gives the stability. That's the opposite. And then how do I control? I control by varying its velocities, which gives you a momentum equations. We generate a momentum equations by which there will be a coupled force which causes you to control. This control, we do it automatically by sensing its current position in the X, Y, and Z directions. Okay. Next. So what are the challenges which we have? Endurance. See, endurance is depend upon the energy that you carry. The energy carries depends upon the density of the energy of that battery. Then energy density of the battery, that is how much discharge rate that battery can give. And if you have a larger payload in the same form factor, the same sizing, same weight matrix, my battery requirements comes down. So this is what, there's a compromise which we have to take off. Then we have a controller. What is my actual bandwidth? Every controller or a motor will have a actuation system. That actuation has to handle this. So sometimes it's a fin control. I told about propeller control. There will also be a fin control. Fin control is a aerodynamic control. We have a thrust vector control and a aerodynamic control. Then what is the effects of the aeroscopic effects when it's turning at high speed? And for a micro zones, even the Reynolds number becomes an important aspect. Ultimately, it falls down to thrust to weight ratio, which is always to be greater than 1. And then sensor accuracy depends upon how much it is. It cannot have a body. The body vibrations can cause a sensor to be inaccurate. It can cause disturbance in the sensor. And those disturbance cause the variations value. And also a sensor drift may happen. The sensor, what reading sensor is giving now and sensor after some time may not be having the same accuracy. And ultimately, especially when I'm speaking about the speed and limits at which it is going, there's going to be heat generated, and that heat will affect your electronics. So either we have a cooling system or the electronics to be ruggedized to withstand those temperature. This is where the thermal management comes in. These are some of the challenges. I have not put in other challenges for you because like we have electromagnetic interference and electromagnetic compatibilities, the optical devices which we have got certain image classification requirements. Those things are not put it because it's going to be heavy, because this was aimed at first year and second year of engineering students. So I have limited to certain basic things, but there are many other challenges which you face as you build and convert it into a system for which it has to run in operational mode. And the second challenge is no human should get affected by this. That means though it's an unmanned vehicle, if it crashes in a populated area, for example, it goes in a populated area, it crashes, somebody is going to affect. So also, if I have running it with certain frequencies, if I got a transmitter receiver station, that is from the ground I'm controlling it, a pilot is controlling it, those frequencies should not affect the other frequencies operating in the region. Like your mobile phones, other things should not affect. This should not get affected by those frequencies. So these are the other areas which I have not put it in here, but those are the areas we have to also consider when we actually design and running the system. Next. So if you have a modern airframe, what we like to have? We have a outside structure. The structure is called mainly airframe, and we have a modular design, and it has to be crash resistant. What we build it, either it should be metallic or carbon fiber composites. We prefer carbon fiber composites for one is it is silent and stealth. Second, it gives me a weight reduction of at least 30% from metallic, and for a smaller systems, it's easy to build if I have got a mold made. Next, power. So we use mostly lithium-ion batteries or lithium-ion polymer batteries for the power system. There are systems which are used fuel cells like hydrogen-based fuel cells, but that is a different system which commercially right now it's not being heavily used. But that's also a technology where gives me a higher endurance for a slightly medium drones. Then solar cells and energy management ICs which we have to put. That is the complete battery management system, the energy management system. Navigation, we work on devices for the INS system, which will be again integrated for the GPS system. But in case the GPS denied environment, I have to work with some other technologies like SLAM and terrain mapping. Based on those terrain mapping, I needed to follow the track and take the feedbacks. So this is a GPS denied environment also will encounter as we go on. Then payload. I put a camera is a strapped on, that means it's a stationary camera, or the camera has to be motion then it is a gimbal. That is gimbal. If I am locking onto some target, just gimbal according to my body frame and the target body frame, it has to position itself. So that is the requirement which I have to put. Then some radar system I may put, and I may have a communication relay which gives me back into the ground station the image, or to the co-drone, what we call a distributed architecture, where there will be a 4 or 5 drones working together, and they may share the resources and come and work in a commonality. For example, one drone may have an IR sensor, another drone may have an optical sensor, and the processing may happen differently, but they share the resources. So this is the next technology which we may have. Then there's a propulsion. We mostly, or many of the drones which you see are electric motors, but the longer versions, larger versions, which we have to have, need to have on a turbojets. But these engines are currently mostly are used either Rolls-Royce or GE are the premier people who are making, and most of things are taken from them. We have IC engines, small piston engines, people have developed in-house inside the lab, but there also the efficiency matters. And we prefer normally a hybrid where electrical and one of the fossil fuel based engines are there. See, and the next component that is basically will be the avionics. We have in the avionics, what we call is the flight control computer or the onboard mission computer. The IMU, initial measurement unit, which measures the current position of all the 6 degrees of freedom. Then there will be others like magnetometer, barometer. These are the areas. We have a communication link. The communication will be a link from ground to earth, or some or point-to-point communications between two different drones working in synchronization. A SATCOM or a MANET mesh, where the entire communication is distributed over a mesh. And then there is a complete ground control station, which will do the complete mission planning, variation the missions, if the drones have to do some mission variations. This can also be an automated or a human controlled. And for this, there's a data link which happens. Now, our second is the data link is generally wireless, but people are now, based on the recent experiences that are seen in the tethered with fiber optic tethered drones are also becoming a more and more efficient and being used. Especially in the recent wars that people have followed, they have given very, very high accuracies. They have overcome the entanglement issues. They also overcome the bandwidth problems of transmission of a wireless because of this fiber optic cable. And a command and control, what we normally call it as a C2 station. Next. Then if you see multi-agent systems. So if you with AI coming in, multi-agent coming in, what we have is a swarm. Swarms can be dozens, hundreds, thousands. What will a swarm of drone will? It will make a create a, if it is especially in a battlefield, it will create a saturation. Saturation, I mean, your sensors can detect certain numbers. It cannot detect beyond that numbers. So sensors get saturated. So they will not become undetected. It can create a collateral damage because at a time if you see 100 flies or 100 bees coming and attacking you, how will it be? You can handle a 1 fly, you can handle a 2 flies. So hundreds of them come. And then the failure also, 1 or 2 may fail, but still the rest will continue. So these create a situation. These are the swarms which are now being used extensively. And then there are biological swarms which actually mimic a bird. Underwater, they mimic a fish. So biomimic vehicles, they become extremely stealth, undetectable. Especially if I go into underwater, it becomes undetectable totally. So, and this creates a master. So they create a coordination technologies. That means each drone is a relay node. It creates a mesh from one drone to one drone. That means if I to transmit to the 100th drone, it need not necessarily the first drone has to transmit to 100. First drone to second drone may relay to third drone. So this relay happens, and you, with a minimum power and minimum bandwidth, you can transmit across the stations. And this formation is controlled, like a bird formations, their formation. And there will be virtual leaders. So what happens? in the formation, one drone will be a first leader. After some time, the drone will come back, and the second drone may take over the leader. This gives me a longer endurance because the leader will have the first higher drag. So he gives resistance. He consumes more power. Then he comes back. The second one goes. This way I do a power management. This will help me in giving a more endurance to the system and better formation. And we are working out with a simultaneous launch. In the simultaneous launch is in a tube, they may come out simultaneously, or in a launcher may have multiple tubes, or there may be multiple catapults, or there may be some kind of a mechanism where, like a roller mechanism, one after one, they come up. This is what people are speaking about, and then they synchronize in the air. There are many swarm programs. I just flashed it for your reference. Next, please. So these are the major programs. Especially, we have programs across the world today. We do not know how many programs are actually running. So many programs are running today. Because when you see even a small, today clashes are imminent, becoming almost an imminent between the countries. And every time you see, people are attacking with swarm of drones. So much of programs are running. Even in institution level, programs are running. Small colleges have seen people are working on 5-6 drone swarms. Next. Then comes the stealth technology. See what happens if a drone is going and I have to use for an offensive purpose or for a surveillance purpose, my drone should not be detected. And for that not to be detected, how will the drone detect? Drone will get detected by ground radar. Drone will be detected by its thermal signature. Drone will be detected by its image. So I try to create those. By radar construction means I work out a certain absorbing. Radar becomes like a Doppler. If it's an active radar, it relays, sends a signal, comes back. So I had to given some absorbers. So my body will be such a way that it tries to absorb. Similarly, the reflections gets distributed. So the edges, the geometry I work. Then my IR image, infrared image, the infrared bandwidth, I ensure that it gets shielded. I make this motors. Earlier, the motors used to be outside. Now I make the motors. Into a duct. We make the rotors ducted. This causes what? This sound comes very low. We make it silent. So acoustically, we don't discuss. And emission, that means whatever is if it is especially if it is a chemical propulsion or fossil fuel propulsion, we ensure that the emissions are controlled, which will not be detected. These are some of the cases which we heard. Next. People are coming out with a high speed. High speed is people are coming without a supersonic weapons. These are strike drones. They go at a very high speeds, up to 400 kilometers per hour. The issue is here again, temperature management is the issue. And I have seen with work, even with electrical propulsion, people going at 400 meters per second. So we need to work on thermal management, and these create an interception phenomena that is incoming, not only incoming drones, any object incoming gives very high attack mode. There are glide vehicles, which I don't call it drones, but they are slightly bigger thing, which air breathing engine, they go with much higher speeds. And these are being developed today. And then like a rocket propulsion, scramjet propulsion engines are also available, which go at a Mach 3 and plus speed. Next. Next slide. Then area in which fly. We have a drones now. You see normally all the drones flying less than 3 kilometers altitude, but there are now medium altitude drones have come. They come at 15 kilometers, which makes you ground interceptions difficult, especially by laser interception or my small rocket interceptions make difficult. I need a bigger articles, higher energy, and much higher altitudes. They are extensively used for today for surveillance purposes. And then Space-based also, we have drones which are come. They are like a balloons. And next generation will be the orbital drones. Next. So what do they carry? Why they carry? One is they carry electro-optic or IR camera systems, which give me the end-game tracking. Then they carry what we call intelligence. That means it scans the frequencies of the ground radars or the frequencies that are going around, and it eavesdrop them. Then kinetic munitions. So it carry a bomb, and it's a self-destructible, what we call kamikaze systems. And it may carry some sensors which may detect the chemical emissions. It may carry a radar like a synthetic aperture radar, which give me on ground what is there, and also if there are certain just below the ground, just on the surface of the ground, below the ground, more clear, resolute images, and it may work in a different weather conditions. They are also used for certain weather predictions and also cloud formations. Then they carries a communication relay network, which I already explained. It also carries a electronic attack. That means it carries a jammer. That means it carries some energy level which jams the incoming drone, so it can be jam any ground station also. Jamming in may mean the electronic which is functioning in the ground, its frequency or something is get jammed. That means it doesn't become operable to the requirement for which we work. And more, then there are logistics and payloads for medical supplies, ammunitions, last mile delivery, or even in sea, if I had to drop some maintenance equipment, these are being used. Next. Next, please. So if you look at the counter drone system, I'm now going to touch upon a little bit on the counter drone system. If you see this object, this is a sketch. If you see this object, there is a drone coming. I detected the drone, then I may jam it. I may change its direction, called by spoofing, what we call as spoofing. I may kill it by some gun. I may kill it by a rocket, or I may kill it by a laser weapon. Next. So, what I had to do, we had to build some kind of a kill chain mechanism. What I had to do, first I observe. That means I observe means I sense, I detect. Detect means I should know the latitude, longitude, and altitude of the position of the incoming drone. Then I should compute it. Compute it, I have to have a kinematic equation. By the different points, I should know what velocity, what speed, what attitude it is going. Then I have to orient and I have to classify. Classify is what type of, is it a drone or it is a bird or it is something, I have to classify. And I have to give a direction in that stage. Then I have to decide whether some human will operate, whether I have to kill it or whether it's a friend or it's a foe. If I have to kill it or I have to jam it, I have to change its direction, I have to recover it. What is the method? Whether I have to use a human or whether it's an automated system. Then I assign it and create the effectiveness. So if you see, this is how the layer, there is a sensor layer, the effector layer, where individual weapons, lasers are there, tactical layer, where the controller, the complete fire control is there, the next level, then the operation level, where the brigade level, they take the complete operation decision, and finally, the national command policy of theater level, it's the centralized theater level. Next. So in this, if you see, how do I do what I was talking about jamming? What do I do? I have a bandwidth of, I know that the incoming drones or incoming system has got a frequency on which it operates, but I do not know the exact frequency. So I create a wideband. With different frequencies, I create a higher pulse engines. So at certain frequency, it gets attacked and it neutralizes because of this higher energy that comes in that frequency. Their transmission system gets affected. Or I send a directional beam on that to that point of time. Then The other thing which we jam is the GPS signal. That's why we call GNS signal. That means it gets denied. But normally today drones have, even if the GNS is denied, they do a terrain mapping and return to home. So how to handle that? That is the next level of jamming. Then these jamming, what is the range at which we can work on it? Then what we call GPS spoofing. Spoofing is you give a false GPS signal so that it assumes that this is the correct GPS signal and goes in a different direction and what the intended direction it is to be done. But automatically you have to build a anti-spoofing also in your system because this is a game continuously happening. Then cyber takeover. Cyber takeover is you actually create this, you get into their firmware and go into their mission system and ensure that that drone works according to your command rather than the adversary or the other person's command. That is actually you are taking over the computer. But then everybody has got an encryption. So how do you beat is a cyber? That's again a challenge. Next. So if you have radars, we have different type of radars: pulse Doppler radar, phased radar. I'll just cover this. You read because for you radar technology is not covered much in the engineering colleges, but there are different bands of radar, and for example, if X band radar, I may get some range. We have a Ka band radar, Ku band radar, where my resolutions keeps on increasing, but then the technology also becomes challenging, and accordingly it is built. The sizing comes down if the higher the my bandwidth band of the radar. So this is where we develop it, and also the power requirements changes and cooling requirements changes. Then there's a passive detection called RFDD detection, radio frequency direction detection. It gives me the direction and it gives me the position of the radar through a triangulation method. Next. Electro-optic, the sensor layer with electro-optic, which has got, these are all the detection. See, I gave you detection. So we use EOIR detection for the, and then we use an artificial intelligence to classify this thing. And this has got both day and night problems. And in night, we have to do a lot of classification backend systems to match with the day values. And it also limited by weather. There's an attenuation available once it's having a rainy or a fog, there's some kind of attenuation. Then drone position detect, what we call detect, the DPD. It is basically we intercept the mavlink of the telemetry or aerospace protocol. These can be done only if I know the other protocols, and that's why it's cannot be done that easily. But there are systems today available on this. Next. The most important is if I had to increase my accuracy is fusing this. That means I got an input from radar, I got input from camera, but all are in different formats. My backend today, AI-based classification should ensure that the information received, some will give me an angle information, some will give me a position information, some will give me a range information, some will give me an accuracy of some value, the other one will give me accuracy of different value, but ultimately I have to build the target image for a controller or the command. He is not bothered what is there outside. So he takes this, for example, acoustic, he gets a noise, sound. So based on these things, the command and control station fuses this data. This is one area which is a heavy work is going on. I raise this issue because this is where area where the AI teams can work on this, and with the machine language and AI can do that. Next. Most important now that is coming up is interceptor drones. What it does is it actually chases it can be done on a tail chase mode or head on mode. When we know that there are drones coming in, we launch a drone. First we calculate the position through our sensor, whatever you are now seeing, the sensor networks. You calculate the position and give the information to the drone at the ground itself. Then it takes off. Then it knows which direction it has to go. It comes with a certain speed. And what type of launch, whether it's a vertical launch or it may be horizontal launch. But normally we prefer vertical launch. I just given a plot of engager speed. It vertical takes off, Then it pitch down. Pitch down means it changes its attitude, goes towards the incoming drone. The drone can be incoming, drone can be outgoing. That means drone can be away also. It can go, or it can do can maneuver and turn and hit from behind, depending upon the damage criteria which we decide. Next. So I have given the different speeds, endurance for these interceptor drones, and drones itself will have some kind of a tracker themselves, because once the radar is there, radar accuracies are there, and once the radar hands over with certain accuracy, the onboard system will actually calculate, go to the micro level, and with that then it gives a command to the controller to give the exact direction and give a point accuracy. It can be a direct hit, or it can be a proximity detonation. Proximity detonation means we come to a very near range, we initiate explosive, and in the explosive blast and creates a area of kill there. Otherwise, it can be also be direct hit. Direct hit requires more accuracy. The engagement series is like explained: queue, classify, authorize, launch, navigate, acquire the target by the onboard system, engage, and then you do an assessment of what actually has damaged. Next. So other next is we can have a missile, short missiles, like what we call in V-shrouds or some other missiles, which are the short range missiles, or a man portable missiles, which has got a small rocket, small guidance system in that, and we give the information to it and it hits it. It can be, like I explained, it can be direct hit or proximity hit. Next. The other one is high energy laser. Here, when I launch a high energy laser, I've got a small beam width, and that goes and hits on the target airframe, drone airframe. Here, the dwell time is very important. So if I have a 2-second dwell time, my energy requirement is more. If I have got a 5-second dwell time, my energy requirement is lesser. But then, if I need to have a 5-second dwell time, the drone speed should be low. So it is all the trade-off which happens upon target. The more higher the laser energy is better, but then there is a challenges. The bigger the laser, your mass, velocity, mass requirement, power requirement, everything varies, and also building that a higher energy lasers is not easy. World over, also today, more than 50 kilowatt radar are not easy. So this is what it appears. So normally what we find generally in use are 2 kilowatt, 5 kilowatt, at the most 8 kilowatt radars. But then it becoming bulky. But then this is one area which silently kills, and people are preferring it today. Then it's a gun system. It's like a machine gun system. You fire rapid guns and magazine guns onto the drone, because the altitudes are smaller, especially the near altitude, they do effective kill. Next. Then you have microwave. What is microwave? You have seen radar. A radar has got a transmission and receiver module. Now I don't have a receiver module. I give a high power energy into this transmission, and this transmission, then I give a 4 or 5 beams. I join the beams at some central point. The energy becomes almost 4 times now because of the 4 beams joined, and this causes a slightly wide area. For example, if I got a swarm of drones, this is the best way to kill it. Then I do a net, non-kinetic, because I release something like a net system, and that net system captures the drone, like earlier used to catch the birds on the net. It is better in the crowded environment, so that the collateral damage on the ground is minimum. Next. So what are the emerging technologies and future trends? The drone itself is autonomous, but the artificial intelligence in the classification, identification, for example, face reading, face recognition. For example, if I'm going in an area where I want my people not to be hit and only the enemy people to be hit, or identify who is friend or who is foe, who is a person, target of a person identification. So I need to do a lot of backend AI systems. These are there. Then which sensor to do what activity? I need to put a lot of agentic AI system into there. Swarm intelligence, I already spoke about it. Swarm is the order of the day, and intelligent swarm means which drone has to take, whether outside weather, what is the weather, how my frequencies has to change accordingly. And based on the information from one, or if one or two drones have fallen down, how the others have to require. And some may identify the target identification. Some may create a kill mechanism, which has to take which has to be a sensor mode, which has to be attack mode. All these things become the next generation. Though it's at I don't say it is at the TRL level 2, 3, but it is now reached somewhere in 4 is a quantum navigation. Once there's a quantum navigation, my drifts are very low. I don't need GPS, and especially magnetometer, quantum magnetometer type, if I use, I can have a long endurance without a GPS. So the cold atom interferometry gyroscopes are being developed, and personally, I'm not seen in the operational stage in a real drone, but they are crossing the laboratory bounds today. Then the direct energy is maturing, what I explained, high power system. They are also maturing very well, and they are being extensively used nowadays. Next. So then the hypersonic interceptors, I already spoken about it. The hypersonic interceptors, they are going to be the urban air mobility. In India itself, there are companies which are building this urban air mobility, but because of its dense traffic and all, they don't want it to be crash landed. And if it has to carry human, especially in the evacuation times, in the cyclone areas, flooded areas, also the human safety, the safety protocols, clearances are to obtain. And currently there is no policy on this. The business may emerge based on the policy of the government of India, but that has to pass through many safety norms before they come through. But these will be going to be the future, where there's unmanned drones which carry both payloads and humans, especially in a critical times where it is unsafe for a human to go, or it is difficult for human to go. This may be utility. Especially, for example, if I had to use a Leh Ladakh region, transportation of goods, this is the best way. Next. So what are the challenges? Endurance. For endurance, you have to come out with more and more battery technologies, solid state technology. People have to work, research, build a technology where with the same mass, same form factor, you get a higher energy. Safety, I explained this. This is the next step, work on which, how you make it extremely safer, and how your artificial intelligence can build the safety algorithms. Then how the sensor or transmission beam qualities, how it cannot be gracefully degraded, how to avoid this degradation in a difficult atmospheric conditions. Then cost asymmetry. For example, if the incoming drone cost is only 4,000, 5,000 rupees, and if I had to use a weapon which costs 1 lakh rupees, it doesn't make sense. So I had to create something which by low cost interceptions or a low cost system. This is where it has to work. Then swarm communication. This is your next challenge. These are the challenges which people have to work on now. Counter stealth. That means there's a stealth. How do I handle the stealth? How do I detect the stealth? Navigation. I already said when the GPS denied. Indoor. Small insect drones are coming which go into the indoor systems. And regulations and ethics. So how the legal frameworks, what suggestions we give to the government, how do we convince the government policy makers that this is safe, and these are the things which we have to put it. Next. Why this drone matters, I need not have to tell you all. The latest scenarios have clearly identified that this is going to play a big role, at least in the next 5-6 years. I cannot predict beyond this, the way things are changing, but this is going to play a big role. And also in the domestic sector, especially for agriculture purposes, exactly spraying your fertilizers, or identifying the total crop content, monitoring the crop content, monitoring the large complexes, monitoring the crowd management. Everybody is using it. Everywhere it's a strategic. Drone will become a more strategic component now. Engineering domains that is demand: embedded systems, RTOs, flight control, RF antenna design, computer vision, AI for target recognition, control theory, guidance navigation control, high power electronics, structural, aerodynamics. So there are many organizations which are there: DRDO, defense startups, IDEX challenges. If you see, every IDEX challenge now that are coming up, whether industry challenge or a innovation challenge, has at least one drone system in that. So you go for the IDEX challenge, you build your systems, go for the IDEX challenge, apply for it, and if you get like selected, you get IDEX fund. But there are also many people, angel funders lined up for people who got IDEX challenge. If they prove, the angel funders are ready to invest in them. So you get a seed capital. Then once you build it, you get a bigger capital, people coming to you and investing more for you. Then there are global OEMs which you can work for you. Academic research. In fact, the DRDO's Center of Excellence is promoting heavily, and with the many of our academic institutions are getting benefited based on the COEs. It has opened up a large development, especially at the TRL 4 level juncture. It has opened up. We also has got a ER and IPR, which will give you on the basic research. And DRDO is very good in supporting, mentoring, reviewing, and you will build something of global standard. Actually, DRDO scientists, once you get into it, handholds you very well, guides you, and you come out with a very good standards which will make you ready for the world market. In addition, there are many government schemes also, like ANRF funding and DST funding. There are other government schemes, MSME funding. There are many other government schemes which you can work on. Next. So key takeaways: drones are a dual-use technology, both for civil and military applications. No single sensor or effector wins the US battle. That means you got to know, have all like radar, RF. I gave you whole of things. And how much of intelligence you have, how much of data you generate and intelligence you build in defines the next generation. And in all that, but still the human judgment remains critical in lethal decisions. Cost
Sir,
asymmetry
excuse me,
is a
sir.
challenge. India's movement is now, indigenous drone cable is a national security imperative, which is such a huge population, so many academic institutions, everybody working. Let us I feel all of you together, make India strong, and globally we'll position ourselves, and we have a global market driven. Economically, we also have a global market driven. Thank you very much. This ends my presentation for today.
Thank you very much, sir, for your enlightenment and inspiring session. We will now begin interactive question and answer session. Participants are requested to post their questions in the chat box. Please keep your question short, clear, and relevant to today's topic. Sir, we have an interesting question from one of our participants. Sir, with drone technology evolving so rapid, what skills and projects would you recommend engineering students to focus on today's to contribute to the future India and drone ecosystem?
The technology of drone is a multi-domain subject. One is you can be an overall conceptual designer, but then you have to master one of the areas. I've given you so many areas there, and every area has got a next generation. If I take structure should be cheaper, lighter, at the same time it should withstand the strength, and it has to be mass producible. The scalability. How do you ensure the scalability of the structure? How do you ensure the thermal management structure? These are going to change. And then how you can use AI applications to design it quickly. For example, what design was taking about 6 months or 7 months, you have to bring it down to days or year, maximum a few days. And how do you produce it faster? Whether 3D printing will work, or you have to get a molding design, you have to work on the manufacturability of it. Like this, each and every element of it has got. There's no single application. If I say launcher itself, how do I launch multiple drones? How do I position each drone? How do you give a input system for each drone about its current position and where it has to go separately to those drones? So these are the things. So everywhere there is a intelligence in AI involved. There is a ground engineering knowledge is involved, analysis involved. Based on that, it becomes a multi-domain system. So my suggestion is have an overall idea, but master one area, master it.
Sir, one of our coordinator want to ask questions, sir.
Yeah,
Miss
go ahead.
Hasini, over to you.
Good evening, sir. I'm Hasini, a first year BTech student. My question is, what are the most important skills engineering students should develop if they aspire to work in drone and anti-drone systems at DRDO?
No, I didn't get it. Why? What do you want?
So, what are the most important skills should engineering students develop to aspire their work and work in DRDO at anti-drone system and drone system?
There are two questions. One is work in DRDO, work in anti-drone systems. So let me concentrate on anti-drone system. First is you should understand either it's anti-drone system, any system. You should understand what is the physics behind it. So once you develop the skill of identifying the physics behind the system, then you can do anything. I may speak anything, but then if you have to understand, if I say optics, what is the physics behind that phase? How the lens shaping has been done? What is the convergence of that optics? How do I adjust the focal length? These are all the physics behind it. The skill that you have to develop is understanding the physics. Next, DRDO. You have to work in DRDO. You have to go go through the DRDO selection process. But then today, you don't think that you are working inside DRDO. Scientist is a DRDO. You may work in an industry which works for DRDO. There are so many private industries which are working because DRDO has got a development come production partner. And as a process of that, any DRDO project, the industry is going to work in tandem. Also, DRDO's funding system is there. You can work from that. Not only DRDO, you can work from the army funding, navy funding, or the civilian funding agencies. So don't limit now yourself that I want to be only in DRDO. The world is the limit. If you have got a strength, you have got a work, you have got a determination, and you please understand any work doesn't come without challenges. To speak, it is easy. To build some system, you have to struggle. You will face some difficulties. And when you face some difficulties, you will face some failures. From failures, you will learn lessons. You don't get detached, then you build the system. Okay?
Sir, please switch on your camera, sir. Thank you, sir. Sir, another question from Sahasra, sir.
Yes, sir.
Good evening, sir. I am Saharsha, fourth year student. Sir, what are the biggest challenges India faces in developing indigenous drone technology?
Scale of production.
Okay.
For example, if I have to make 1,000 drones today, I need 1,000 motors. I need 1,000 propellers. The scale of production is the challenge. It's not the technology, in my opinion.
Thank you, sir.
Thank you, sir, for such a detailed explanation. With your permission, sir, we will move to the next question. Sir, can I take one more question, sir?
Yeah. This will be the last question?
Yes, sir. This is the last question.
Okay. Take it.
Sir, what are the major drawbacks of drone technologies nowadays, and how to overcome the
The major drawbacks is payload management, sensors. These sensors, if you had to have, we have very few people working on them. Everybody makes a small drone and flies, but then the application for which the drone has to work, there people are not able to actually implement it properly. So we have to work on the various sensors which have raised. Most of the sensors, many of the subsystems, we don't have a full-fledged building strength today in the country. We have to build on that.
Thank you, sir, for patiently answering all the questions. Now, I would like to invite our coordinator, Ms. Hasini, to deliver the vote of thanks. Hasini, the virtual stage is all yours.
Good evening. Good evening, everyone. My name is Hasini, and I'm a student coordinator at KIYE Foundation. It's a privilege to deliver the vote of thanks for today's session. On behalf of KIYE Foundation, I extend my gratitude to our respected speaker, Y.Sreenivas Rao Garu, for spending his valuable time with us. Thank you, sir, for sharing your valuable time, knowledge, experiences. Your words have truly motivated us and dream bigger and work harder and believe in our potential. We'll truly appreciate your patience in answering all our questions and guiding towards a brighter future. I would like to sincerely thank the KIYE Foundation team for leadership, our mentors, organizers, volunteers, and every team member whose dedication and hard work made this event successful. Your efforts behind the scenes are deeply appreciated. A special thanks to all the participants for their enthusiastic presence, active participation, and thoughtful interaction throughout the session. Your involvement made this program truly meaningful and successful. Once again, thank you, Y.Sreenivas Rao, sir, for the inspiring lecture with your valuable guidance. We are truly grateful for your time and encouragement, sir. Thank you, everyone, for being a part of today's session. Thank you. Have a wonderful evening ahead. Jai Hind.
Thank you, Hasini. A heartful thank you to our respected speaker, Dr. Y. Sreenivas Rao sir, for sharing his valuable time, wisdom, and experience with us. To all the participants, never stop learning, never stop exploring, never stop innovating. Work forward, build a strong and self-reliant India. That brings us to end of today's S-Talks lecture series. A few quick announcements. Do follow KY Foundation on Instagram, YouTube, and LinkedIn. Share today's session with someone who will benefit from it. Stay tuned for the upcoming lectures and stay connected, stay curious, keep building. Thank you, everyone. Thank you for joining